This section of the text deals with equations in quadratic form. The first one is pretty easy to recognize as a quadratic because it has the x squared in it. And it is in the form of a quadratic in terms of x. And if you'll notice, I said a quadratic in terms of x. So you look to the middle term to see what it's a quadratic in terms of what. This one is also a quadratic. It has a squared term and a non-squared term. It's a quadratic in terms of 3x minus 2. The third one, also a quadratic. You notice it has a quantity squared. Then it has that same quantity as the middle term, not squared. And then it has a constant term. So quadratic equations always have a form, typically 3 parts, a squared part, a non-squared part of the same type, and then a constant term. What you have to do is recognize these quadratics or equations in quadratic form and be able to factor them. This one is easy to factor. I hope you notice that it factors into x minus 3 times x minus 2. Minus 3 times minus 2 gives you plus 6. And when you add the middle terms, you get minus 5x. Well, this, if it's in quadratic form, I should be able to take the middle term and put a substitution for that. Let's say z. So I'm going to rewrite that. Plus 6, I'm not going to change. I'm going to call that minus 5z. If I replaced that with z, I hope you notice that this means this one could be a z squared. Now it's easy to recognize the quadratic, and notice it's going to factor the same as this one. The only difference is, because I used a substitution, z equals 3x minus 2, then when I solve these, if I were to finish solving this, I would go x minus 3 equals 0, x equals 3. And this one, I would get x equals 2. But in the ones of quadratic form, because I used a substitution, instead of x equals 3, I have 3x minus 2 equals 3, and 3x minus 2 equals 2. I take my substitution and I place it there, and then I solve. So here I get 3x equals 5, x equals 5/3. With me on that one? And then on this one here, again, in place of x, I'm going to put 3x minus 2. 3x minus 2 equals 2. 3x equals 4. X equals 4/3. So when you have a quadratic form, your substitution has to be placed in, and then you have an extra step of solving. What do you think the substitution would be in this last part? Well, I hope you said the substitution was 1 over 2x, so that's what the substitution is. So in the first problem, remember we had x equals 3 and x equals 2, but because we're using substitution, the x is really 1 over 2x equals 2. 1 over 2x equals 3. To solve this, multiply both sides by 2x, so I get 2x times here, 2x times here, so I get 1 equals 6x. How about x equals, divide both sides by 6, 1 over 6. All right, let's do this one. Multiply both sides by 2x, That cancels, so I get 1 equals 4x. Divide by 4. 1/4 equals x, but I like to write it x equals 1/4. So there are your two answers using substitution. So when you have an equation of the quadratic form, figure out what the substitution is and imagine it, this equation, I really imagine it like z squared minus 5z plus 6 equals 0. They always factor just like the quadratic. Factor the quadratic and then use your substitution to do an extra step of solving. They're really... All right. let's try two more equations in the quadratic form. This time it's a little bit hard to recognize what the quadratic form is. So I'm going to rewrite this a little bit as 1 over r minus 5 times 1 over root r plus 4 equals 0. So now, if I want to think of a substitution, I always go to the middle. If that was my z, if z was equal to 1 over root r, what would z squared be? One way to find out is to physically square both terms. When I square z squared, I get z squared. That was a no-brainer. What happens when I square this? Square the top, I get 1. What happens when I square root r? I get r. Whoa, look at that. Perfect match. So, I do have quadratic form. That's my r, that's my z, and this is my z squared. So, let's think of this in terms of substitution. So, we said that z was 1 over root r. That's our key that we have to keep in mind. Because it looks so complicated, I'm going to rewrite this with my substitution. Remember we said 1 over r was the z squared, so let's rewrite it. Z squared minus 5z plus 4. Now that looks a little nicer to factor. Do you know what the factors are? Factors for 4, 2 and 1, 1 and 4, minus 1 and minus 4, right? Minus 1, minus 4. So z equals 1 and z equals 4. But I'm not done. I use substitution. What is z? Z is 1 over root r. So 1 over root r equals 1. Let's solve that for r. Well, let's square both sides. I need to get the r by itself. So first of all, I'm going to get 1 over r equals 1. Let's multiply both sides by r to clear our fractions. And I get 1 equals r. So r equals 1. There's one answer. Let's do the next one. Z is really 1 over root r. So 1 over root r, root r equals 4. Let's square both sides. So 16 and 1 over r. Multiply both sides by r. So I get 1 equals 16r. Let's divide by 16. So r equals 1/16 in this case. So I get r is 1 and r is 1/16. Now I should check, since my problem started as a fraction, when I get my r's, I want to make sure they don't put me in a situation where I have undefined fraction. That means 0 in the bottom. 1/16 will work here, it will work there. So we're good. This one, tricky to set up. You notice it's not equal to 0. So we have an extra first step. So rewrite it. 5a plus 6 root a plus 1 equals 0. Again, we're going to use substitution. So if that's my z, if z equals root a, what do you think z squared would be? How do I find it if I don't know? Square the z. Square what I decided the z would be. So z squared equals a. Oh, so this is going to be perfect. If instead of a I write z squared, 5z squared plus 6z plus 1 equals 0. Now this one looks hard to solve. Factor 5z plus 1, z plus 1. Well, that works. All right, let's finish solving. Z equals -1 and z equals -1/5. I got two answers. Do you know why the answer is no solution? When I try these back in the original, they don't work. -1 times 5 is -5, plus 6 times the square root of -1 equals -1. This is not real. And if I'm solving for real answers, I can't get an answer. Now, if we allowed imaginary numbers on these, you could. And the same thing happens with the others. So don't forget to check your answers in the original to make sure they are valid answers and work in the problem. All right, good luck.